Hi, my name is Tyler Beddingfield. Thanks for viewing my story map today, which is being submitted to the 2021 annual meeting for the Society for Range Management. The story map is called Measuring Willows, Ground Sampling versus sUAV, Comparison of Willow Metrics Collected with Ground-Based Sampling Methods and a Small Unmanned Aerial Vehicle. So this video is being included in the introduction. I'm going to start out with giving you a little guide to this story map. If you'll notice, at the top of every section there's a little sound bar. Just click on that and you can hear yours truly narrate the section for you. When you get to the results section, you'll notice a stark lack of written material there. There's a sound bar there as well. In that narration, I will take you through the entire slideshow, which is roughly 30 figures. So hang on to your hats, folks. It's going to be a bumpy ride. To start out, what I want you to do, if you haven't already, is open the map that is included at the very beginning of this presentation. You'll notice that each site is briefly described and there's a little picture in there. You'll notice some cool folks doing some cool field work, and I hope that you thoroughly enjoy interacting with that map. So let me introduce you to this project. This is the Crow Creek Riparian Project. This is just one small portion of that project. The rest is a multi-year large project that's going on in the University of Wyoming Department of Ecosystem Science and Management. If you have any questions about the project, please feel free to email me. My contact information is located in the acknowledgments and references section. Don't hesitate to ask any questions, dumb or not dumb. I'm more than happy to take 3 hours out of my day to perfectly craft my response to your email. And that wasn't sarcastic. So imagine you're a rangeland manager and you are responsible for understanding and being able to characterize riparian vegetation on your landscape that you are in charge of. The question is, how do you go about doing that? Well, there's a few different ways. The first way, you can do traditional ground-based sampling methods. Line point intercept transects, belt transects. There's a slew of other different ways that you can do it, including Daubenmire, and other ways that you can observe by hand the riparian vegetation. However, let me just tell you, that kind of sucks. As someone who has done a lot of that, it's not very fun. Riparian vegetation is typically dense, woody material, and I personally don't like getting stabbed in the eye, and neither do your range techs. So another option that you have is satellite imagery. Unfortunately, a lot of the time, that imagery is too grainy to really be able to use, and at some point you're going to have to go out in the field and take a look at what you're dealing with anyway. One of the intermediate approaches that this project has employed and is using to estimate, how effective is this technology is drones, sUAV, or small unmanned aerial vehicles, or aerial systems. These little drones you can take almost anywhere. It does depend on how remote your area is, but you can take them and get a quick flight in, and then you process that imagery later, and you can derive some interesting metrics from that, and it's way faster and it's way easier than doing ground-based sampling. One note, it is important to know for you that although this is a presentation of vegetation data, the Crow Creek Riparian Project is an eco-hydrological project where we are going to be taking this vegetation data, analyzing it, and then applying that, connecting it with hydrological observations. And those are collected from a variety of instrumentation as well as thermal imagery. Our instrumentation includes shallow groundwater wells, stilling wells in the stream or stream gauges, as well as there's lots of soil moisture sensors out there. There's a ton. So this is going to help us inform water and energy balances, as well as we're going to try and estimate water usage from the willows themselves. And I think there's going to be some other cool stuff. So stay tuned. I'm sure more research regarding the eco-hydrological aspects of that is going to come out in the next year or so, and it's going to be really interesting, so stay tuned. So this video, I'm going to briefly go over everything that you can find in the written sections, but if you don't want to get a headache from scrolling through all of that, just keep this video on and I'll kind of take you through everything. So our methods, first we started using ground-based sampling surveys. These are based on Herrig et al., typically employed by the BLM for vegetation monitoring and assessment. So we did grid-style line point intercept to get a basic vegetation inventory at our grass and grass-like dominated sites, which are sites 2 and 3 and about half of 6. So these results are available down in the results slideshow. We also did modified belt transects. They're modified in the sense that, typically when you're doing a belt transect, they're very narrow, about a meter or less in width, and then they're very, very long. Our modifications to these belt transects, they're very wide. They're about 10 meters by 15 to 25 meters, so we're looking at about 150 to 250 square meter areas for each transect. And part of the reason they're so big is because we needed to measure large willows. These willows have massive basal circumferences, or they range in size. Some of them are less than a meter in basal circumference. So that gave us some ground cover estimates from the shrubs themselves. The main thing that we wanted to quantify with that is volumes from the belt transects. The main volume that we did was cylindrical volume, so just your basic cylinder. The shrubs are cylinders, so we did volume that way. In 2020, I took an allometric sample, which includes several more measurements, and got an allometric volume based on those. There's not a big difference, but you can see that there is a nice behavior around the 2.5 basal circumference meter, where you see volume really start to accelerate after that. The next thing we did were GNSS surveys, or very highly differential GPS surveys. We used real-time kinematic receivers, the MLID Reach RS2 base and roving receivers in particular. And what we did is we basically set up the base and gathered this very, very precise location. And then what that base does is it sends its corrections to the roving unit. And what we did is we collected our points with the roving unit. Let's say that there's this willow here, right? And essentially what we did is around the edge of the canopy of that willow, we would pick points. Usually it was a random number of points, with emphasis placed on like changes in direction in the willow canopy. And we would just pick points around that willow, and that gave us some interesting data. We would plug those points into QGIS, create a polygon based on the cluster or the particular canopy that we were dealing with, and you can see those results down in the results slideshow as well. But it's really interesting stuff. Gave us some percent willow canopy cover per site, and after that you can kind of see the difference between how we were measuring from the modified belt transects versus the GNSS GNSS was kind of also an intermediate between ground-based sampling and satellite imagery. These were done on the ground, still kind of taking your measurements by hand, but you're using spatial information to really analyze that data. So you're not like, I didn't have to get stabbed in my face by Willows in order to get these data. And I believe for all 6 of our sites, it took about a day and a half. So it was extremely fast, and really, really nice, to say the least. So the third method we used were obviously the sUAV surveys. It's important to note that further post-processing needs to happen, quality checking needs to happen, as well as the thermal imagery processing has not yet fully begun. So keep that in mind when drawing your conclusions about the sUAV survey efficacy. But essentially what we did, we took a DJI Matrice 200 series, and we equipped it with 4 different cameras, Mica Sense Red Edge, multispectral 5 and 10 band cameras, as well as the FLIR ZenMuse XT2 thermal and RGB camera. So essentially we put ground control points down. These points help us stitch all the photos together that the cameras take. We flew sites 1 through 3 together, sites 4 and 5 together, and site 6 was flown on its own. And essentially, once we got these photogrammetric results, we plugged it in. And today what I'm going to focus on are the digital surface models that were created from the RGB imagery, but essentially everything that we create is helpful. In addition to the digital surface models from the RGB, we use the multispectral results to calculate NDVI, and you can see in the results section that for sites 4 through 5 there is a change in NDVI throughout the season, which makes sense because if you're not familiar with NDVI, it measures essentially how green something is, and so you can see the decrease happening throughout the season. We start flying in very early June, and then we end in mid-September, and you can see the greenness of those go down. So it's really interesting. It's something that we expected to see, but it's just cool to have that verified. So these results from specifically the thermal photogrammetry, those will be presented at a later date, I'm sure. But it's important to realize that, although the RGB and the multispectral imagery really help us understand the vegetation, behavior, and characteristics, the thermal imagery is what we're going to use to tie that in with hydrological observations. So it's going to be really interesting. You should stay tuned. Those results should come out in the near future. So I'm not going to go into the results too much because I'm going to spend a lot of time narrating that, and you can just kind of listen to that like a podcast. Like you're viewing the story map and you're on your way to get Starbucks or something. I don't know. So I will leave that for the most part, but one thing I want to mention is that the results section is structured in the way that the sUAV results are posted first, because that's obviously the most important, that's the coolest, it looks really cool. But remember, these are very preliminary and quality checking is ongoing. First, you'll be able to see the digital surface models for all 6 sites, and then you'll be able to see the changes in NDVI. One of the next things that you're going to be able to see are dense cloud screenshots. That's essentially what they are, and you might think that you're actually looking at a photograph of the sites at first glance, but they're actually very high resolution dense clouds. After that cool drone imagery, you'll start to see the normal figures that you would see in an article. The first ones are essentially comparing willow base circumferences with willow volumes across all of the sites that we measured those at. And after that, you'll be able to see the results from the ground-based sampling, from LPI, from the belt transects, as well as the GNSS results, where you'll be able to see the polygons that were created that represent the canopy cover. And then finally, you'll be able to see the Crow Creek watershed, where all of this information gathering and assessment takes place. So do scroll through that, listen to the narration. It should be really interesting. Going through the discussion and conclusions now. Stick with me. I know we're at 16 minutes now, roughly. So, essentially the sUAV technology is really nifty. It starts to address some of that spatial resolution issues, that environmental science is kind of struggling to grapple with. And, we're a lot of the times, people who deal in remote sensing of ecosystems, that's kind of the goal, is to get the resolution down as high as possible. You want to be able to see the venation on the leaves. And what that does is it addresses an issue with uncertainty in modeling. The problem with that is, you can only get down so far. At some point, the technology is really great right now. The sUAV technology is really great, and it does really address that spatial resolution problem. However, it doesn't fully answer all the questions that we have, or that you have, or that any land manager curious about sUAV technology for their own personal research on their landscapes is interested in. So, you can get a lot out of sUAV technology, but you're still going to have to do some ground truthing. If you do choose to use sUAV technology for riparian shrub measurements, there's a lot of information that you can get out of it. But it's not perfect for every application. If you are dealing with a very low budget and you can't afford the buy-in, then you can't. I believe that our equipment setup is about $60,000 to $65,000 just for the drone and the cameras, and on top of that, you need computers that can handle the data processing, as well as programs. And depending on if you already have that, or if those things are subsidized for your organization, that might be a limiting factor to using this, as well as know-how. You have to have a drone license. You have to have an area where you can fly drones. So those are some of the limiting factors to using sUAV technology. But if you can afford the initial buy-in and afford the programming and all that stuff, it's really handy. I know for me personally, I really do not like doing ground-based sampling because it takes forever. People have issues identifying plants, or they have issues, getting proper height measurements, or, people aren't always trained the same way. And so there's a lot of labor-intensive, time-intensive, unhappy people sometimes doing these ground-based sampling methods. And it takes forever, You're out there for almost every day taking vegetation measurements by hand, and then you have to go and analyze it, and it doesn't thrill me personally. I would much rather just go out there with at least one other person, fly a few sites, come back for the day, and analyze and process that imagery, and not have to be out there for forever. But it kind of depends on how remote your sites are of concern. The other thing to note is that LiDAR can also be applied for obtaining these similar kinds of metrics that our study is looking at. And my grad student that I work with, Victor Stromberg, he took some ground-based LiDAR, and we should be able to compare those results within the next year, maybe. That's kind of a conservative time frame. But I'm going to be graduating soon, so, we'll see what happens. But, so in addition to ground-based LiDAR surveys, you can also get LiDAR cameras or LiDAR sensors to add to your sUAV equipment list, your wish list on Amazon, I'm sure. So yeah, to conclude, the data that we've gathered is really handy. We gathered the data in a way that a lot of people are used to gathering data by hand. But we've also been able to explore using differential GPS or GNSS surveys as well as sUAV technology and kind of compare those with each other and see, hey, what works, what doesn't work, what are the limitations, what are the advantages of using all these different things. And, personally, I found a lot of fulfillment in this project, but I hope that if you're a land manager and you're viewing this story map or you're listening to me talk on and on and on and on, you thought this was going to be a poster presentation. I hope that you can take something away from this and that, sUAV technology has been around for a long time, but, it's hard to know if it's worth it for you. And so I would pose to you that if you have the budget, if you have the know-how, if you have the interest, I would say go for it. It does really reduce the amount of time and frustration that maybe your crew of range techs is having to struggle with if they're trying to quantify riparian vegetation along streams on rangelands. But if you are, if you don't have the budget for it, and if you are happy using the methods that you are used to using, obviously sUAV technology can help you, but it doesn't have to make or break your estimations. It's just a really cool application for reducing your uncertainty in some places, and it can be advantageous if used correctly, or with some good understanding of the limitations and advantages of sUAV technology. One last thing before I close out this presentation. All parts of this research were conducted on the lands of the Arapaho, Cheyenne, and Sioux. Personally, I believe that as scientists, we need to start taking responsibility for the effects of colonialism, especially for Western science, on not only indigenous nations, but indigenous science. And we need to really start to value where our research has been made possible. So please keep that in mind as you go through the rest of your Society for Range Management annual meeting experience. And if you have any questions, please email me at tbedding@uyo.edu. Again, that contact information is down in the acknowledgments and references section. And thank you for visiting my story map.